Hi, happy first day of spring. It's March 19th, 2020, the earliest vernal equinox here in the United States in 124 years. The last time was in 1896. And in this video, I just want to explain what is an equinox. Equinox comes from the Latin equal night, and the common belief is that it's 12 hours a day and 12 hours of night, but that's not necessarily accurate. Here I have a globe and what equinox is, and then I'll explain further. But an equinox is when there's equal sunlight in both hemispheres, because the sun is directly over the equator. Now this is a globe that's tilted about 23.4 degrees, so it's not like this, it's like that. And the Earth spins on its axis around the sun. So let's make believe there's a sun right here. On the globe there are two hemispheres, the northern hemisphere and the southern hemisphere. And if the sun is right here, you can see that the southern hemisphere has a more concentrated sunlight. On the other side, this is going to be interesting, you can see that there's more direct concentration of sunlight in the northern hemisphere, and it's more spread out in the southern hemisphere. So during summertime in the northern hemisphere, there is a greater intensity and concentrated sunlight, but in the winter, that sunlight is now spread out over a larger area. There is a greater distribution of that energy and light from the sun. See, here it's circular, but there it's elliptical and spread out. And that is what creates the seasons, summer versus winter. And all that is due to the tilt of the Earth. So you could do that experiment in a dark room. You could shine the light directly on top of a surface, and you would see like a very bright circle. But if you tilt the flashlight, you could see that the circle now spreads out into a relatively dimmer ellipse. So in summary so far, if the sun is right here, you could tell that it's going to be summer in the southern hemisphere, because the summer hemisphere is tilted toward the sun, and there's a less concentration of sunlight up here in the northern hemisphere. So it's heading toward the autumn and winter over here. So that's why when it's summer in the southern hemisphere, it's winter in the northern hemisphere, and vice versa. As the Earth moves half a year later, then you could see that the northern hemisphere is tilted toward the sun than the southern hemisphere. So now the northern hemisphere has a more direct concentration of sunlight, and the southern hemisphere has a more distribution of sunlight, or less concentrated sunlight. But let's talk about the equinox. What happens when the Earth is right here and the sun right here? The same thing would happen over here, but for you to see, the sun's here, it's directly over the equator. So as the Earth rotates counterclockwise, the sun would be over the equator right here. If the sun is right here, then there's an equal distribution of light above and below, and that's really what the equinox is. It doesn't mean 12 hours a day or 12 hours of night. In fact, where I live on the northern 33rd parallel, the real day that's closer to 12 hours was March 16th, which was 3 days ago. Additionally, you could see that neither hemisphere is pointed toward the sun more than the other. So again, there's an equal distribution. And so that's a rudimentary explanation of what an equinox is. Now let me conclude with something a bit more technical. The atmosphere around Earth acts as a lens. If you know about convex and concave lenses, it refracts light, because light is transmitting through another medium, causing it to slow down, causing a refraction or a bending. It's just like if you have a glass of water and you put a straw through, you'll see the illusion that the straw has bent, but it hasn't. Likewise, the sun's light rays travels through space, enters our atmosphere, slows the light down by Snell's law, and refracts it or bends it. So I say that to say this: when we see that the disk of the sun rise, it hasn't really risen yet, and when we see the sun during sunset as it goes below the horizon, it's already below the horizon. It's an optical illusion. We see the sun even though it's already set. I think that was quite interesting. So we call it sunrise when the disk of the sun, or the very top of the sun, rises above the horizon. And we say sunset is the time when the disk of the sun falls below the horizon. So I believe it's 6 to 6.5 minutes difference, which technically creates the illusion of a longer day. And another thing, at the equator, almost every day of the year, the day is about 12 hours. Exactly 12 hours a day, 12 hours at night, roughly at the equator every day of the year. So I hope that you like that. I hope that you learned something. I hope to make another video on April 12th and explain the difference between the astronomical vernal equinox, which is something like today, versus the ecclesiastical vernal equinox, and use that to explain why Easter, or Resurrection Day Sunday as I reference it as, why that falls on different days of the year. Sometimes it's late March, sometimes it's early April, mid-April, late April. And why is that? Well, I hope to make another video then. So I hope that you enjoy springtime as the days continue to get longer and longer and longer until the summer solstice, and then it will get shorter and shorter and shorter until the winter solstice.